We're now going to look at circle theorem property 4, and it is called angle in a semicircle, AIS for short. And this theorem involves the diameter of a circle. And what we do is we draw a triangle using the diameter as one of its sides, such that we form an angle at the circumference, like that. So we've formed a triangle using the diameter of the circle as one of its sides, and the theorem says that the angle formed at the circumference will always be a right angle, 90 degrees. Okay, let's apply circle theorem 4, and you'll notice now, because we've done quite a few circle theorems, we'll be using more than just one of them. So here is our circle diagram. We've got various lines and angles inside. We're given one angle and we want to work out angles A, B and C. So there's not always an obvious place to start, but you should start thinking about circle theorems. You should start thinking about, diameters and chords. Well, the one that we've just looked at is called angle in a semicircle. So what we could do is take the diameter, first of all, of our circle. That's clearly the diameter, that line that I've drawn now in red, because there's the center O. So this is clearly the diameter, goes through the center. And what I'm going to do is I'm going to form a right angled triangle using the diameter as one of its sides. So I'm going to trace over this line, and I'm going to trace over that line, and you can see that we've formed an angle at the circumference here using the diameter as one of the sides of that triangle. So this total angle here at the circumference is going to be 90 degrees. The total angle is going to be 90. So if the total angle is 90, that means C must be 45. So our first answer is C equals 45 degrees, and that is because of angle in a semicircle, AIS for short. So we've now worked out C. C is 45. We now have to work out A and B. Now again, we could actually work out B using circle theorem 2, which is called angles at the center and the circumference. You can see this angle B is formed at the center, and you have an angle 45 formed at the circumference. Now that is possible when you take this line to be the chord. So if we take this line to be the chord, and what we do is we draw a triangle using that chord as one of its sides, such that we form an angle at the center, like that. What I'm then going to do is draw another triangle using the same chord, such that this time we form an angle at the circumference, like that. So using this as the chord, the angle formed at the center is twice the angle formed at the circumference. So B is going to be twice 45, which is going to be 90 degrees, and that's because of angles at the center and the circumference. So that was using this side as the chord. Okay. We now want to get angle A. So in order to get angle A, what we could do is we could actually now switch our attention, and we could use this bottom side as the chord, and we could draw two triangles from the same chord, and the angles at the circumference would be the same. That would be using circle theorem 1. That's one way we could do it. So again, if we take this bottom side here to be the chord, and again we draw a triangle using that chord as one of the sides, and we form an angle here at the circumference, and we take the same chord and draw another triangle from it such that we form another angle at the circumference. What we'll discover is that A and C are the same. So if C is 45, then A is also 45. And that's because of AC, angles at the circumference.